there. Welcome to Astraveo's continuing education series, where for our podcast listeners, we talk about mathematics, the physical sciences, of course the natural world, and our personal favourites, astronomy. Now, you know Joseph and I are all up in and about astronomy. We get super excited about that stuff. So let's get going. For today's episode of Astraveo's continuing education series, we're going to be looking again at area and perimeter, this time of triangles and circles and maybe even cylinders as well. If you remember in our last episode, we talked about squares and rectangles specifically. Tonight, we're going to be talking about regular triangles. That means they're not irregular, they're not strange or funny shapes, and circles, and we may delve into cylinders as well, because that's sort of an extension of a circle. So let's remind ourselves just a little bit what we did last time. So for a square, that's not the world's best square. There you go. I think you'll remember I'm not the world's best drawer. The perimeter is just the length, 4 times the length, because all the lengths are the same size, 4L. So this is L for a square. And the area is just length times length, which is L squared. Now for a rectangle, slightly different. We have length, width. The perimeter is 2 times the length plus 2 times the width. 1 length, 2 length, 1 width, 2 widths. And the area is just length times width. Well, now we're going to deal with a special case. Why don't we start with the circle? A circle is a very special geometrical shape in mathematics. I'll try and draw a circle as best I can. That is not too bad, actually. Okay, so we have a couple of things to define. We have the radius, which is the distance from the center to the edge of the circle. But we can also define a diameter, and that is 2 times the radius. So as you might be able to guess from the diagram here, if that's one radius, the diameter is all the way across. It's a radius this side and this side. Okay. Now, the other thing we have is we have the circumference. Now, the circumference is basically our perimeter. Because let's start here at, say, 12 o'clock. I don't know how well I'll be able to draw this. The circumference is the distance all the way around the circle. Circumference. It's a bit of a strange spelling, but there you go. Okay. And so, let me switch back to my purple pen here. Circumference, circ, equals. Now I'm going to introduce a very special number here, the number pi. The circumference is 2 pi, that's the symbol for pi, r. Now we know that 2r, twice the radius, is the diameter. So it's also pi times d. These two things are identical, 2 pi r and pi d. Pi d is the diameter, d is the diameter, r is the radius. Now this number pi is a very, very special number. It goes on for ever and ever and ever, basically. And so pi, that's the symbol. It's almost like a Greek letter, the Greek letter pi, like that. And it's spelled Pi. It is 3.14, I think it's 159, ... Now that number goes on forever and ever and ever. It goes on to infinity. So it's an irregular number that goes all the way out to infinity. There are zillions and zillions and zillions of decimal places. I am not one of those people that know them all. There are many, well, nobody knows them all, of course, but there's some people who can cite pi to hundreds, thousands of places, decimal places. I don't know how they remember, but they can. I tend to remember it as 3.14, and sometimes this 159 is rounded up to be 3.142. So I tend to remember it as 3.142. Now that's an approximation, of course. So if you want really high accuracy in your calculations for something to do with structural engineering, for instance, or aerospace, or any form of sort of science, you really have to use a lot of decimal places to get it right. For our purposes, 3.142 is just fine. So we've actually got a perimeter already of the circle. It's just the distance all the way around. So the circumference is another way of saying the perimeter of a circle. Circle. If you remember last time when we did this series for the square and the rectangle, we defined the perimeter as just the distance all the way around that geometrical shape. Well, that's exactly what the circumference is. Okay, so we already have the perimeter of a circle. Now, the area of a circle has a formal definition. So the area is pi r squared. So there's that funny symbol again, pi. It's this formal relationship between the diameter and the circumference. I'm actually going to write it out maybe here. Pi is the ratio of the circumference to the diameter of a circle. Okay? It's a very special geometrical relationship. Well, the area is just pi r squared. Now we know that the radius is the diameter divided by 2. So we can write here pi, instead of r, we can write d divided by 2 all squared, which is pi d squared divided by 4, because 2 squared is 4. So you could, for the area of a circle, you could either use pi r squared, or you can use pi d squared over 4. I actually prefer pi r squared myself. So for instance, again, let's give ourselves a question. You know, I'm big about questions because that's what a school-aged student will have to do in one of their tests or exams before they get to use it practically. And this kind of information, you're probably talking 3rd grade, maybe 4th grade, which is a sort of 9-year-old, 8-9-year-old, maybe a fraction older depending on which education system you're part of. So let's make ourselves some space as we normally do. Okay. Yeah, I'm going to get rid of my little diagram here. I'll leave some of this up for now. So you might see an exam question or a test question that says, for a circle of radius 4 centimeters, what is its perimeter, or circumference, same word. You'll probably use circumference actually. Circumference and its area. And its area. Now again, I think you all know me well enough by now. What's the very first thing I'm going to do? That's right, I'm going to draw myself a diagram. As best I'm able. Not the world's best Picasso, but there you go. That's not too bad. Okay, little circle. And we know, we were given this, that its radius is 4 centimeters. R equals 4 centimeters. Well, we have these two formal definitions for area and circumference of a circle. We know that the circumference is just pi d, or 2 pi r if you prefer it. Twice the radius is a diameter, we know that. So I tend to work in, I remember it's 2 pi r, so I'm going to do 2 times pi times r, which is 4, which equals 8 pi centimeters. Now what you could do is if you plug pi into your calculator, you'll get 3.14159, blah, blah, blah. I don't know all the numbers. So we could approximate this to 8 times this number. Now, I'm not sure I can do this off the top of my head. 832. This is going to be something like 24. This is going to be something like 27.2. But I'm going to leave it as 8 pi centimeters. Okay. What about the area? Don't forget, the area also, I'm going to give ourselves just a sort of separating bit here. The area is just pi r squared, or you can use pi d squared over 4, but I was brought up on pi r squared. Now that just means for this particular example, r is 4, so it's 4 squared, which equals 4 times 4 is 16. 16 pi, don't forget the units, centimeters squared. Okay, so we have a circumference of 8 pi, but we have an area of 16 pi. Centimeters squared. So 8 pi centimeters for circumference, 16 pi centimeters squared for area. So that's really it. As long as you know those two definitions, the definition for a circle is either 2 pi r or pi d, because 2r is d. I prefer 2 pi r. And the area is pi r squared. Could be pi d squared over 4. Some people are taught like that, depending on your education system. I was brought up on pi r squared. As long as you know those two definitions, if you're given the radius of a circle, you can always work out its perimeter, its circumference, and its area. Okay, so that's circles. That's as simple as it is. It's really just remembering those two little equations, little definitions, really. And so just while I'm doing this, why don't we tell ourselves this then over here? That's just for memory. For a circle of radius r, the circumference or perimeter is 2 pi r, and the area is pi r squared. So we know that. Now, what about a regular triangle? Now, I chose regular deliberately because irregular triangles, those triangles with 3 different length sides, or very irregular sides, can be difficult. We have to take a next step into trigonometry, and we're not quite there yet. Let's just deal with 2 triangles. We're going to do 2 types. We're going to do a right angle triangle, which, yes, I realize has 3 different length sides, but what we have a 90 degrees angle here. A right angle triangle makes it much easier. And then we also have an isosceles triangle, which is 2 equal lengths, and there's the base. These 2 lengths are the same side, and then of course we could actually have, I'm not sure I'm good enough to draw this, we could actually have an equilateral triangle where all the sides are the same length. So there are 3 types actually. Okay, so there is a standardized equation for the area of a triangle. Actually, we normally start with perimeter. Let's start with perimeter. A, B, C. Now this is going to be A, B, because these 2 sides of the isosceles are the same length. Now in this case, the equilateral triangle, all the sides are the same length, so it's going to be A. Okay, so the perimeter, remember, it's just the length all the way around. The perimeter in this case is going to be A plus B plus C. That's not too terrible. The perimeter in this case, the isosceles, is just going to be the distance all the way around. Is going to be A plus B, which equals 2A plus B. And this one, even simpler, all the lengths are the same. It's just going to be 3 times A, because 1, 2, 3. So for those 3 different types of triangle, a right angle triangle, an isosceles triangle, and an equilateral triangle, the perimeters are really quite simple. You just add up the length of the sides, A, B, C, A, B, so it's 2A plus B, and then A plus A plus A is just 3A. Okay, quite nice. Now, what about the area? Now, the area of a triangle, again, has regular triangles at least, and all these 3 are regular triangles, has a formal definition. The area of a regular triangle equals 1/2 times the base times the height. So that's a formal definition. In fact, I should have done it over here to give myself a lot of space. Area of a regular triangle equals 1/2 times the base times the height. Okay, let's give ourselves a little bit of space as usual. Now for the right angle triangle, we actually know it already. Here is the base length. Here is the height. This is the high part of the triangle. We just have to rotate it. Just going to turn it round. B, C, A. Well, B here really is the base. The height, is there. There's the right angle. That's the height. So that one is quite simple. The area is just 1/2 times the base, which is B, times the height, which is A, It's just AB divided by 2. That's not too bad. Now, what about the isosceles? The isosceles is a little bit interesting. Draw it again. Okay, a little tick mark means it's the same length. This is B, this is A, this is A. Now, we have to work out the height of that triangle. This is not the height, it's a sloped line. We need the height, and it's normally worked out like this. All the way down, forms a right angle triangle, and it bisects the base in 2. So in fact, this entire thing is the base, which means this distance is the base divided by 2. Now, how do we go about working out the height of the triangle? It's a bit tough, we don't know it. But we do know something, we have a special case. Let's just draw half that triangle. There's the height. There's the part of the isosceles. Now there's the 90 degrees. This distance is the base divided by 2. This length is A, and we need to know this height here. Any ideas how we can do it? That's right. We have a right angle triangle. We're in the realm of Pythag. Now, we did Pythagoras' theorem in a previous episode, so we are able to work out this height. We know that the sum of the squares of the 2 shorter sides of a right angle triangle equals the square, whoops, it's not C, I'm used to A squared plus B squared is C squared, the square of the hypotenuse, the long side. Here's question mark, we don't know. Question mark squared plus the base divided by 2, because this is this length, squared, has to equal the hypotenuse squared, A squared. So this really is in the form of A squared plus B squared equals C squared. Okay, we need to get rid of this to get the question mark length on its own. So let's subtract B squared over 2 from both sides. Okay, I'm going to do it how they teach in school. Let's get rid of that. So we're going to subtract B over 2 squared from both sides, B over 2 squared. And we're going to be left with question mark, because these two cancel. Let me change color pens here. Dot, 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 dot. Those go away, A squared minus B squared over 2, B over 2 squared, I apologize. And then, as we know, to get the number of any number squared, we just take the square root, because it is multiplied by itself. So we're going to take the square root, and take the square root of the other side as well. We are left with, I'm running out of room a little bit, question mark, whoops, let's do this. Question mark equals the square root of A squared minus B over 2 all squared. Now it's plus or minus, but don't forget, we don't have negative distances. So we know the length here, the height, sorry, I should say, that's a poor description. The height is just A squared minus B over 2 squared, square rooted. So now when we apply our area of a triangle formula, half base times height, the area now equals, let's give ourselves some room, and get rid of our little equation down here. The area equals half base times height, half times the base, well the base is already B divided by 2, and the height is the square root of A squared minus B over 2 all squared. So the area there is just a little bit more complicated. In the right angle triangle, we knew the height really simply, so it was just half base times height, half AB divided by 2. The isosceles triangle presented us with a complication because we didn't know the height. We had to work it out using Pythagoras' theorem, which is why we've already covered it. It's super important in all branches of mathematics, almost. We know the base. We also know that the the base divided by 2 was one of the lengths. We needed the height. We were able to work that out with Pythagoras' theorem. So now we do half. The base, I have made a mistake. No, I have made a mistake. This is not b divided by 2. I apologize. Got myself all confused. The base of this entire triangle is still b. We needed b divided by 2 to work out the height. The base is still b. Sorry, that was my mistake. I got myself all confused there. Okay, so we've got the area of an isosceles triangle. Finally, let's look at an equilateral triangle, because that's a special case. If you remember, we drew it before I erased the board. Each of these sides is identical. It is, let's call them A. Actually, no, let's call them length L. Now, I don't really like A because we're going to use area shortly, and that's going to be confusing. So if you remember, the perimeter is just 3 times L. 1, 2, 3. Now, to work out the area, we have to be a little bit careful. We know the area of a triangle is 1/2 times the base times the height. Now, we don't have the base, but what we can do is we can drop down from the vertex angle. Here's the vertex angle up here. Drop down a vertical line, join the horizontal, make a right angle triangle, and it will bifurcate, it will split this line in 2. And so one of our new triangles becomes, so we can work out this side. Let's do one of the half triangle. This is L. This is now L divided by 2 because it's half of this. And we don't know this side. We do, however, know that that's a right angle triangle. So what we can do now is we can use Pythagoras' theorem. We worked on this a few episodes ago, if you remember. We know that the sum of the squares, of the 2 shorter sides of a right angle triangle is the square of the longest side, the hypotenuse, L squared. So the sum of the squares of the 2 shortest sides equals the square of the longest side. So we have an L squared over 2. Let's get rid of it. The way to do that is subtract L over 2 all squared from both sides. L over 2 all squared. Obviously these cancel, and we're left with question mark squared equals L squared minus L divided by 2 all squared. Now at this point we can do a little bit of tidying up here before we continue. Okay, so whoops, that was a strange question mark. Question mark squared equals L squared minus L divided by 2 all squared. Well, this equals L squared minus L squared over 4. Now this L squared, because we've got a fraction here, really because this is a whole L, we can actually say this is 4L squared divided by 4, because the 4's cancel, will just give us 1, minus L squared over 4. Well, from some of our elementary fractions, we can combine these two. The lowest common denominator here clearly is 4. We have a divided by 4 and a divided by 4. So let's divide everything by 4. That leaves us 4 into 4 goes once. So we have 4L squared minus 1L squared, because 4 into 4 goes once. 1L squared. 4L squared minus 1L squared is 3L squared. So we have 3L squared divided by 4. Now that is question mark squared. So we have to be a little bit careful. Okay, let me make some space as we always do. Okay, let's see what we have. We have question mark squared equals 3L squared divided by 4. The way to get rid of a square is, don't forget, it's just the thing times itself, so take the square root. So we're going to take the second root, square root, there it is, square. Now this is a multiplication with a fraction, so this is quite a simple expression to take a square root of. Square root of a square is just the thing itself. The square root of L squared is just L, square root of 4 is just 2, and we have a 3 here, so we have a square root of 3 times L divided by 2. Now that's the height of our triangle. So now we know the height of the equilateral triangle. So we should be in business. Let's get rid of all our workings out. We have area equals 1/2 times the base times the height. We have 1/2. The base is just L, and the height is the square root of 3 times L, all divided by 2. Well, L times L is L squared. 1/2 on the bottom, this is really, I'm going to get rid of the 1/2 like that. 1/2 is really 1 divided by 2. Now these two 2's can multiply, so we end up with square root of 3 times L squared divided by 4. So the area of an equilateral triangle actually has a special formula. It's the square root of 3 times the length squared divided by 4. So this is a very special formula for an equilateral triangle. As long as we know the length, we have one number, we're able to work out the area quite simply. Okay, thank you for joining us.